Hi one and all. In today's tutorial we are going to talk about how to design a structure or a building and ETABS. Okay, so I will create the grid lines for structures and I will define its material, its section properties, and I will show you how to scale earthquake records to match the target response spectrum. Okay, and other specifications, okay, load patterns, load cases, okay, how to define earthquake records, okay, and other things. Okay, let's start. I will just click on new model. Okay, I will use built-in setting width. Select this one and I will display unit will be 1 metric MKS. Okay, and still section database will be this one 15. Okay, and still design code will be 36316. okay, this one, which is the latest one, and concrete design code, which is the latest version of American Concrete Institute, will be 31890. okay, this one. After that, click OK. Now here the new model template. Okay, I will fill number of stories. I want to be 25 story structures. Nine. Okay, and in y direction let's it be 7. Okay, and spacing of grid in x directions should be say 6 meter, and for y directions let it be 5 meter. Afterward I will edit the grid lines. Okay, for here just I will put some values, okay, to indicate its simplicity. Okay, after that click here with only, after that okay. Here is our grid lines for a structure which is G plus 24 story has been created. Okay, here is model explorer window, here is the plan window, and here is 3D view window. Okay, we can change and adjust each and every window as far as our requirement. Okay, here the model explorer window will show the project properties, structure layout, okay, objectives and others, each and every story. Okay, we can change the name and we can see the which load has been assigned and displayed in other things. Okay, for now no need this window, I will just close this one. Okay, now I will define some properties, material properties, section properties, hinge properties, load patterns, okay, mass source and load cases, load combination, and etc. For now I will click material properties. Okay, this material is are predefined. Okay, I will just select this 4000 psi. Okay, I will modify show material. Okay, this is according to American code. I will just click OK. There is no need to change some specifications, as the software is wise to choose in the specification and other things. Okay, I will click OK, and I will just add copy of material. Okay, and I will give a name here 3000 psi. Okay, which is going to be used for concrete beam in this structure. Okay, there is no need to change something. Okay, I think I will just reduce this one little bit to be 22. Okay, and other things will be the same as it is. Okay, after that okay, and this is the rebar properties. Okay, these rebar properties will be applied when the structures. Okay, this is rebar, and this is also another rebar. Okay, so these are the predefined by a software. Okay, ETABS. After that I will click OK. Now I will go to define section properties in frame section. Okay, I will delete multiple properties. Okay, no need this one. Delete. Okay, okay. I will add new property. Okay, I will use concrete rectangular. Okay, I will click rectangular, this one. I will give a name, column 0.75 by 0.75. Okay, which is material will be 4000 psi. Okay, and I will 750 put it is depth. Okay, millimeters, and width will be the same, 750 millimeter. Okay, after that I will use this one. Okay, moment of inertia about axis 2. I will use 0.75 or 71. Here I will also use 0.71. Okay, modify show rebars. Okay, I will use PM2 M3, which is used for columns. Okay, material for rebars material will be this one. Okay, and it should be rectangular. Okay, and clear cover will be this one, and I will do not change this specifications because software is also going to determine and choose the suitable rebar size and number of rebars. Okay, so I will leave this one, so the software will be set for it to choose. Okay, after that I will click OK, and I will click OK. Now I will click copy of these columns. Okay, add copy of material property. I will give a name here, column 0.60 by 0.60. Okay, I will use the same material. Okay, I will just change it to section dimension 600 millimeters and 600 millimeter. Okay, so this will be column, not a beam. Okay, the same material will be used, and let's see the software provide the suitable reverse for these ones. Okay, click OK. After that, OK. Now again I will click a copy of this material, the copy properties, give a name, column 0.5 by 0.5. Okay, I will use the same material. Okay, it should be concrete rectangulars, and I will change here 500 millimeters. Okay, same columns. Okay, and the moment of inertia about axis 2 and axis 3 will be the same as we defined for the first column. Okay, I will delete this one. Okay, we have 3 columns. Okay, now I will define beam section, add new property, it should be rectangular. Okay, this one. After that, beam 0.50 by 0.50. Okay, I will use 3000 psi. Okay, it should be 500 millimeters and 500. Okay, I will use M3 design only beam, this material, rebar material. Okay, and let us see the top bars. Okay, cover will be 40 millimeters, and this will be also 40 millimeter. Okay, leave it as the same. Okay, and show modifiers, I will use 0.35 for moment of inertia about axis 2 and axis 3. Okay, and after that, okay, so we have defined beam sections and column section. Okay, after that, okay, now I will define section properties, wall section. Okay, add new property, I will name it shear wall. Okay, material will be 4000 psi and it is modeling type will be shell thin, and it is thickness will be, let us say, 300 millimeter. Okay, I will delete this one as it is extra. Okay, now we have defined beam properties, column properties, and shear wall properties. Okay, now I will just go here. Okay, otherwise I will draw beams, columns, and shear walls. Afterward I will define response spectrum, and I will attach the time history records, mass source, and load cases, load combination, and etc. Okay, let's start. I will just quickly do it. Okay, first of all I will draw the columns. Okay, I will click this one. Okay, for you can use here this one as well. I will click this one. Okay, I will click this column. Okay, and close. Select all stories. Okay, I will use to draw. I will going to draw a column. I will click here. Yes, the column is going to be drawn for whole structure. Okay, yeah, you can see. Yes, like I'm just drawing for one story, but it is going to be applied for whole column sections for a building. Otherwise I can just select and drag. All these columns will be drawn automatically for whole building. You can see. Yes, you can see. Automatically it will be drawn for whole building. Look. Yes. It is very simple. Okay, now here I will just draw shear walls, and after that a few columns and beams and etc. I will just for shear walls I will select this one to be quickly draw wall. Okay, I will use pier. Okay, and shear wall. Okay, after that close it. I will draw here. Here, this side, okay. Okay. Yes, this will be as a two cores. Okay. like we have drawn the shear walls for whole building. Okay, after that I will draw the remained columns. Okay, the same column. Yes, so now there is no need to design other columns. Okay, so in this side the shear walls are going to resist the lateral and vertical walls. Okay, now I will draw beams. Okay, I will select here property type to be beam. Okay, and I will just select here. You can do one by one also, like you will just select draw beam columns brace. Okay, you will select here, and you can do it to drag from here up to here, like this one. Select, but it will take time, but you can do it very simply and easily. Okay, but at the moment I will use this one to be drawn very quickly. Okay, yes. Yes, you can see all the beams have been drawn. Okay, now I will go to the base of the structure. Okay, so you see here each and every story have a columns and beams and shear walls. Okay, now I will just select this one, quick draw this one, quick draw floor wall, and I will use opening, and I will place this as to be opened. Okay. So I will use afterward. Okay, after assigning and defining the beams, the slabs. Okay, I will just define here slab sections. Okay, add new property. I will use slab. Okay, the material will be, let us see, 3000 psi. Okay, and the thickness will be 170 mm, let's say. Okay, and it is modeling type will be shell thin. Okay, I will delete this one, and I will delete this as well. Okay, now I will define the slab section. Okay, I have defined the slab sections. I will assign now to the structure. Okay, I will click this one. I will just select slab which I have defined. Okay, I will draw. Very quickly and for one story, but it will be applied for whole structure. select one story. I will delete this slab from base of the structure because we do not need here. It is a base of the structure. We just select delete. Okay, it has been deleted from this. I will use this one and I will select opening and I will apply here. Yes, you can see it is going to be applied for whole structures. Okay, and I will also assign slab here. Now I will select slab, this one. Yes, it has been applied for all building. Okay, again I will go to the base of the structure. We'll delete this two from the basement. Okay. Just one select. First I will select one story, select this one and delete. For other stories it has been applied. Okay, now I will define the response spectrum. Okay, I will use and choose American Society of Civil Engineering C2016, which is the latest version. Okay, this one, and I will click to add new function. Okay, I will use write response target spectrum. Okay, I will put here as a 1.15 and here 0.51. okay, which is acceleration in this one. Okay, and long period transition to be, let us say, 8. Okay, and set class will be B. Okay, and I will use damping ratio to be 5%. Okay, so the SDs and SD1 will be automatically calculated by a software. Okay, you can see here this is a response spectrum curve. Okay, and after that I will select I will just click OK. Yes, response target spectrum has been defined. I will just delete this one. Okay, after that, okay, now I will define the time history. Okay, time history. First of all, I should have the earthquake records which has been taken from pure ground motion database. Okay, which I have been extracted from the website. I have made also a video about how to extract the earthquake records from pure ground motion database. Okay, you can watch that lecture as well. The link is in the description. Okay, I will just go here. I will select these two records. Okay, and where I have saved these structures I will put there. Okay, first I have to save this one. Okay, I want to save it in desktop. Okay, and I will create here a folder. I will use G plus 25 story structure. Okay, I will save it here. My name also like 25 story. Okay, building. Okay, now Now I will paste that earthquake records here in this folder. Paste. Okay, this is earthquake records in x directions, and this is earthquake records in y directions. X directions and y directions. Now I will define function time history, because I want to use time history function for analyzations. Okay, I will define first this from file, add new function, browse, okay, and specify the locations where this earthquake record exists. Okay, I will select this earthquake record in x directions. Okay, yes, it has been attached. Okay, it is Kocaeli, Turkey earthquake in x directions. Okay, and I want to skip 4 lines. Okay, and number of points per lines, let's see, it will be 5. Yes, okay, and I want to see equal interval values at equal interval to be, let's see, 0.005. okay, after that I will click on convert to user defined. Okay, it's going to define, or you can just click OK, doesn't matter. Okay, okay, this earthquake records in x direction has been defined. I will delete this one, no need, and this one as well. Now again I will select from file, which will be in y directions. Okay, I will select this earthquake records which is in y directions, click this one. Okay, this has been attached. Okay, Kocaeli earthquake records in Turkey. Okay, I will write headlines to skip 4, and number of points per line should be 5. Okay, and I will see that values at equal interval of 0.005. okay, after that, okay, yeah, it is processing. Yes, now we have defined 2 earthquake records. Okay, Turkey earthquake records in x directions and the same earthquake record in y directions. Okay, now I'm going to match these records with target response spectrum. Okay, means like this will be the scaling of earthquake records, okay, to match the target response spectrum, okay, to be used for this structure analyzation. Okay, I will choose function type to add will be matched to response spectrum. Okay, and I will select or click add new function. Okay, I will give a name time history in x direction. Okay, in x direction, time history, x direction, time history analysis, x direction. Okay, I will you can use spectral matching for frequency domain, or you can use the spectral matching for time domain. Okay, at the moment I will use spectral matching time domain. Okay, and I will select target response spectrum, which I have defined previously. Okay, I will select response spectrum, and I will select the preference acceleration time history, which I have also defined, which is Kojali earthquake in X direction. Okay, I will click here. It is showing here Kojali Maslak X direction. Okay, and I will set matching parameter to be program determined. Okay, to be used by program or defined by a program. Okay, but you can select also user defined. Okay, after that I will click match in time history. Yes, it is matching time history process is going on. We should wait for a while. It will complete. Yes, it has been completed. You can see the blue is the actual earthquake records, and at the red it is target response spectrum, which has been matched. Okay, after that you can just convert to user defined. Okay, and this is the earthquake record or the matched response spectrum records. Okay, which is also called synthetic earthquake records. Okay, now I will select for y directions to be matched. Okay, response spectrum, okay, to be matched, and add new function. I will use right give a name time history analysis and y directions. Okay, and I will use spectrum matching in time domain. Okay, I will select response to target spectrum. I will select here equity records and y direction. I will just set a match to be program determined. Okay, and I will click OK, and after that click on match time history. Yes, the time history matched to the target response spectrum in y directions as well. Okay, the blue line or the graphs in blue color is showing the actual earthquake records, and the red is the scaled earthquake records. Okay, after that I will select convert to user defined. Okay, so we have matched or created two synthetic earthquake records in X and Y directions. Afterward I will click OK. Okay, now I will define load case. Okay, I will first define load patterns. Okay, I will here write earthquake X positive. Okay, I will select here seismic, and the code will be American code 716. Okay, I will add. Okay, I will modify this one. Okay, I will select here X directions plus eccentricity will be 5%. Okay, acceleration. Okay, and I will use here 1.15, and it should be 0.51. Okay, in long time period, let's say it will be 8, and side class will be B, and reduction factor will be 7, and system average strength value will be it is 3, and deflection amplification this one and this one. Okay, so after that time period, like approximation, you can choose here, or program calculated or user defined. At the moment I will use program calculated. Okay, and the story range will be from base to the 25th. Okay, after that, okay, I will just add another function, earthquake in X negative direction. Okay, I will add this one. Okay, and I will modify. Okay, I will just unclick or unmark this one, and I will just click this one, X direction minus eccentricity. okay, because it is in negative directions. Okay, I will put acceleration SS value. Spectral acceleration SS value should be 1.15 and this one will be 0.51. okay, it inside class will be B. okay, and the time period should be calculated by program, and the response reduction factor, modification factor, it should be 7, and system error strength factor will be 3, and deflection amplification factor will be 5.5, and occupancy importance factor will be 1. After that, okay, now I will define on y direction, y-axis positive, okay, the same code, okay, and seismic add. okay, I will modify now lateral load, modify lateral load. I will unclick this one and I will just click this y directions and eccentricity. I will put SS value to be 1.15 and this value should be 5.1, and the side class will be B, and response modification factor should be 7, and system error strength factor will be 3, and deflection amplification factor will be 5.5, and the occupancy importance factor will be 1. okay, that is the time period will be calculated by a program, and other things is okay. Press okay. Now y negative direction, okay, add new function, modify this one. I will just select y directions in minus eccentricity, okay, it is value will be this one, okay, and SS value will be 1.15, and S1 value will be 0.51, side class B, response modification factor will be 7, and system error strength factor will be 3, and this will be the same. okay, now I will define wind x direction, type will be wind, and the code will be American code. Add new function, add this function, load case, okay, modify, okay, wind speed, it should be 100, and exposure type will be B, okay, and other things will be program determined. okay, I will do not select user defined for this time, I will select program determined. okay, and top story will be 25th and bottom story will be first story. okay, after that I will click OK. Again I will define for x negative direction, okay, add new load case, modify 100, okay, wind speed, and this one will be first story, program calculated or determined. okay, after that, okay, now I will define wind for y positive direction, okay, the same code, add new load case, modify lateral load, and the wind speed will be 100 meter per hour, okay, and wind pressure coefficients will be program determined. okay, the bottom story will be first story, and okay, now y negative direction, the same code will be used, add new load case, load, after that modify 100, okay, first story, program determined, okay, and okay, yes. Now I will define load case, yes, we have this one. I will add new load case, I will use time history x direction load case, Okay, it will be time history and linear model. I will add this one. The load type will be accelerations in u1 direction. Default will be time history analysis these directions. Okay, and this value will be 137.51. okay, and the model will be this one, model load case. Okay, transient, and let us see the output will be 300, and the output time step size will be 0.1. okay, after that. Okay, now I will take a copy of this one, the copy. Okay, this time will 1, 2, 3, 4. Okay, till 20 story it should be different, having different dimension. Okay, I will select all columns till 20th story, from 10 to 20th. okay, I will select here this one, yes, this one, story by story. This one, 19th and 20th. Yes, I will select. From 10th story to 20th story. 19th. Yes. by story, and I will change it as cross section. Yeah, from 20th story till 10th. Yes. Yeah. I will select story by story each and every column. Okay. Yes. Now I have selected all the columns from 10th story up to 20th story. Okay. Let us cross check whether I have selected all the columns. Yes, I have selected all the columns. Now I will assign different cross section. I will just go to assign frame section properties, and I will select column 0.60 by 0.60, okay, meter. I will apply these section properties of columns to these selected column sections. Okay, apply. Okay. Now look, here is column 60 by 60, and below it is column 70 by 70, 75 by 75, and at the story 21st up to 25th there will be column 50 by 50 centimeters or 0.5 by 0.5 meter. Okay, I will just clear display of assigns. Okay, I will select other column now. Okay, from 20 story, from story 20 up to story 21st. Yes, 21st. Yes, I will go up 1, 2, 3, 4, and 5. Up 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay. Okay. I will select the remaining column as well for these 5 stories. Yes. Okay. Yes. Now I have selected all the columns from story first, from story 21st to story 25th. I will assign different column cross section properties. I will assign column 0.50 by 0.50 meter. Okay, I will select this column which I have defined previously. I will apply. Okay, so all the columns from story 21st to story 25th have different cross section. Okay, and from story 10th, from story 10 up to story 20th have different cross section, and from base to story 10th they are different. Okay, so now I will assign here for beams, columns, and shear walls, hinge and it is reinforcement. Okay, hinge and it is reinforcement. Okay, please do not forget to apply the live and dead load as well. Okay, because so I will select here all stories. I will select this slab shell, all slabs, one by one. Yes, I have selected all the slabs. Okay, then I will go to the assigned shell. Okay, here shell load and uniform. I will select that and I will assign 1.44. Okay, kilogram force per meter square. Okay, I will select gravity and replace existing load. I will just click apply. Okay, I will get the previous selection back and I will again go to for live load, shell load, uniform. I will select this time live load and I will, so the live load will be like 1.53. okay, I will just apply. Okay, now. Okay, sorry, I was not selected these two slabs. Okay, I will just apply again, assign, shell load, uniform. Okay, get previous dead 1.444. Okay, now you can look here, loads has been applied 1.44 dead load and 1.53 live load. Okay, now I will define the hinge properties. Okay, I will just go here, select object type, all beams. Okay, select all beams, close. Okay, I will just assign, okay, frame. I will just apply hinges. Okay, I will use 0 relative to clear length. Okay, I'll use auto hinge. Okay, and I will click add. Okay, this window will pop up, auto hinge assignment data. Okay, I will select the code, which is this one, latest version, American code, and I will select the concrete beam flexural. Okay, and I will select, okay, the freedom degree M3. Okay, and I will use load combination. Okay, so I did not assign load combination. First I will just define load combination. Okay, default concrete frame, user defined. Okay, and okay. So now I will go to the assign frame hinge. Okay, and auto add, select the code, this one, and select the concrete beam flexural, select the degree of freedom to be M3. Okay, and load combination will be, let us see, this load combination, and okay, and other things will be the same. Okay, you can use the reinforcement ratio from current design, or you can use the values for user defined. Okay, at the moment I will use from current design. Okay, after that, okay, now I will put 1 here, the relative distance. Okay, and I will add, okay, the same specification as we have given in 0 relative distance. Okay, after that press OK. Yes, we have defined the auto hinge for beams. After that, okay. So it is near to complete. Yes, all the hinges for beams has been assigned, okay, and created for whole structure. For the confirmation, you can go to the define and go here, frame wall nonlinear hinges, and click show general properties. Okay, this is the beam hinge which has been applied. Now I will select object type columns, okay, and will assign frame, okay, and hence it is the same as we have defined in case of beam. Okay, here I will choose the code and I will select the column, complete column. Okay, I will use PM trim 3, okay, the load combination, okay, and other specifications you can change. Okay, you can choose the program calculated or user defined calculation. Okay, but I will use program calculated. Okay, and shear reinforcement and other things you can change. Okay, after that, okay, now I will put 1 for another side. I will just add, and I will choose the code and also the column. Okay, now I will select the degree of freedom to be PM2M3, and the load cases I can change, and the shear demand at flexural yielding by shear capacity will be I want to select to be program calculated. Okay, and concrete column behavior and other things I can select and do some changes. Okay, the shear reinforcement spacing ratio. Okay, that will be from current design. After that I will click OK. Okay, now I have defined the auto hinge for column at the relative distance of 0 and 1. Okay, after that I will just click OK, and it will be applied for whole columns, for all the columns, okay, of the structures. Okay, this processing is going on. Yes, it is process is completed. Okay, the hinges for column has been applied. Okay, for all columns you can look here. I will just maximize a little bit. Okay, yes, the fiber hinges for columns and beams has been completed. Okay, now I will just check here for shear walls. Okay, I will just go for elevation view. Okay, I will go here, object type, walls, select close, show selected object only. Here shear wall, I will select all the shear walls. Okay, I will select shear walls. Yes, this one as well. I will select it one by one to precisely and correctly apply wall hinges, fiber wall hinges for shear walls. select. Yes, all the shear walls has been selected. Okay, now I will just go to the assign. Okay, assign shell. Okay, wall hinge. I will assign auto hinge fiber PM3, which is used for wall. Okay, add. Okay, and I will apply. Okay, look here, the hinge has been applied for all shear walls. Okay, I will get previous selection back, and I will define reinforcement for hinge. Okay, I will go to shell and define reinforcement for wall hinge. Okay, I will use uniform rebar ratio. Okay, you can use also from current design or from specified rebar layout. Okay, you will define here the rebar layout. Okay, it is geometry, reinforcement, inflectoral and shear. Okay, inflectoral tile. Okay, material, distance, area, and other things. Okay, and zones you will define here, and after that you will click OK, and you can use that specified rebar layout. Okay, reinforcement, but at the moment I will use uniform rebar ratio. Okay, I will put vertical rebar to be 0.011. Okay, and horizontal, we will need to see, it will be 0.0027. Okay, I will click apply and OK and close. Yes, the reinforcement has been applied. Okay, so now we successfully applied all the hinges for shear wall, hinges for beams, hinges for columns, everything. Okay, so now I will just select I will select object type, floors, select, all floors will be selected. After that I will assign shell, diaphragm, and diaphragm D1. Okay, apply. Okay, diaphragm will be applied for whole thing. Okay, so now everything we have defined and assigned, everything is completed. Now the structure is ready to start the analyzation. Okay, now I will click run analysis. Okay, and after analyzation the structure result will be achieved. Okay, so I will click run analysis. Yes, it is process is ready to start. It is creating analysis model and it will take some time, so after that we can look to its results. Yes, the analysis is completed. Okay, now you can look at the deformed shape. Okay, and you can display different response spectrum response story plots. Okay, like maximum displacement, drift, shear, upper strength, moment, and etc. and others. Okay, you can just look at the moment and bend moment diagrams and other things. Okay, so now the model is completed. Thank you so much for your attention. I hope this tutorial will help you to design a building and define response spectrum target response spectrums and match the respective codes with that response spectrum and proceed each and every step of the designing and analysis. Thank you so much, and I request you to please subscribe my channel and press the bell icon for notifying you of updated uploading video. Okay, so thank you so much, have a good time.